Hi there, I'm Aaron Petritz and I'll show you a project I've been working on as of late. It's a polymetric, polyrhythmic, and microtonal music making environment written in C++. I proposed the term poly with an asterisk here, since saying polymetric, polyrhythmic, and microtonal every time is a mouthful. Anyways, the intent is to offer novel approaches to creating music in a software-centric environment that strays from traditional norms. This allows for new instrumental idioms, which are plenty in the world of physical musical instruments, but rare in the digital space where a lot of modern music experimentation is taking place. Most software, A, uses a MIDI keyboard for input, restricting pitch capabilities, and B comes in the form of an audio plugin, which limits rhythmic flexibility, due to the fact that digital audio workstations mimic many aspects of traditional music notation. Computers need not read sheet music, which led me to making gemuPG, an abbreviation of Generative Music Polygrid. Let me show you how it works. So, when we open the standalone program, we get this two-dimensional grid. Here, areas can be placed by selecting the right tool and left-clicking. These can be considered two-dimensional counterparts of the arguably one-dimensional tracks found in DAWs. Within these, you can place generator blocks, which form the sound of the area through additive synthesis. Now, we don't hear anything yet, because we ought to tell the area which frequencies to output. Let's start placing some sequencer blocks around the sides of our area. So, evidently, we now have a looping sequence with a length of 8, matching the area's circumference. I made it so the type and values of placed blocks are randomized within reasonable ranges. Considering the relative type blocks that just got placed were naturally straying away from 12-tone equal temperament already. 4 types of sequencer blocks are implemented. Absolute, which allows for setting an absolute pitch. Relative, which adjusts the frequency as an offset to the previously set one. Note, which allows selecting a note from the 12-tone equal temperament system. I know this deviates from the microtonal aspect, but it makes it a bit more accessible. And lastly, interval, which allows for setting the amount of equal subdivisions of the octave, as well as the amount of steps to go up or down within that scale. Let's add another generator block to our area. If we right-click this block, we get a menu where we can set various parameters, such as amplitude, waveform, and frequency multiplication and offset. They're called frequency factor and relative frequency respectively here. Let's have the sine generator be the first overtone. Let's place another area with an L shape over here. This one has 10 sides. We'll place a generator block inside and load a sample. Set the root frequency and done. Let's place a sequencer block here and set its type to interval. I want to work in 15 edo, equal subdivisions of the octave, for this area. So let's have this block move the pitch up by 5 steps. I'll copy and paste these, change some settings around, and add an absolute frequency sequencer block here too, just to reset the sequence. Now we have a 10/8 polymeter going on. Let's go into the settings of our first area and change its subdivision setting to 1/5. Crank up the release time to its maximum to make it sound a bit nicer, and adjust the amplitude a bit. Now we turned it into a 5/4 polyrhythm. By placing a generator block outside an area, we can add a continuously playing drone sound. I'll save this real quick and load up a couple more projects, just to show you a couple more examples of what's possible sonically. The video will fade out from there, so thank you very much for watching.